Hey everybody, welcome to Alta3's live stream. I'm Sam, as you can obviously see by my name here, nice little name placard. How are you guys doing?
Hey, all good.
I'm good.
It's Monday. Woo!
And it started at 3:30 this morning, except Sean is 3.
Monday fun day.
Yeah.
How fun. Well, what I wanted to talk about today was getting into playing around with classes with Python. So just a little bit of background with classes and Python and kind of my understanding of classes up until very recently. I have been a scripter with Python for probably 3 years now. I've been using Python to go through and make a lot of fun, cool little scripts. I've not really been a developer with Python, is what I've learned. And part of that is my lack of understanding the purpose of classes. So what I want to talk about tonight is just a little bit more in depth about classes, even than what we go with our Python basic students, just to give us an idea about, well, how we can improve our usage of classes. So this actually came from a few discussions I had with Stu and BJ a little bit of code review I got from BJ as well, just trying to figure out kind of why we were using classes. So initially, I had BJ and I both made a solution to a greedy pig game, which is just a dice rolling game. Let's figure out how to use classes to do the dice rolling, kind of like we've got in Python basics. But BJ, being very smart, very much more of a developer and much more experienced of a developer than me, pointed out to me that there was a part of my code that could be exploited very, very easily. I set somebody's ability to have a dice roll be very open to be changed whenever we wanted to, whenever somebody else wanted to. So that got me thinking, and talking to Stu a little bit about classes got me thinking too of how we can go through and start using classes kind of as they're intended with Python, which actually is to be a defense mechanism primarily against yourself. So with this, I've got 3 little examples. Hopefully they all work. But what I am making in this example is a little zoo. We are going to be making our own little zoo with just adding some animals in to our zoo. So if we take a look at our class animal right now, notice we've got a kind being animal, very bland, generic here. And then we've got an init. This initiates the class, it instantiates it, instantiates an object of the class, I should say. And notice we've got, the name. It's going to be a kind, maybe a kangaroo, what cage number it's in, its jumping power, what X position it has and Y position and where it's facing. So we can start to say it's in a cage. It's at the middle of the cage at position 0, 0, and it's facing north. Is essentially the idea here, because we want to make a game where we've got a little kangaroo jumping, hopping around, turning around, doing a twirl, doing a backflip, whatever. And ultimately, what this is kind of junior level programming, admittedly. And I'll talk about why in just a little bit. But with this, we've got all of these attributes about this one type of animal very, very easily edited, very easily exposed here. So what we do is, well, we've got the init. We say speak, and it just says hip hop because I couldn't come up with anything cleverer than that. And then it will go through, and we've got a jump method. So whichever direction you're facing, you go that way when you jump, is the concept there. Describe is just a very long, detailed sentence saying, well, where's the kangaroo at? Or where's the type of animal at? And then we go down here, and we've got a little create zoo function, which we don't really need to look at that. All it does is it's a while loop going through and asking, hey, what type of animal do you want to make? And in our case, we're just making a kangaroo to start with. And we'll go through and we'll create it. And we'll see that down here, once we create it in line 60, we'll print out all of our animals that we make, and we'll go through and tell each animal to jump. And we'll see what happens. So first of all, we are going to make this bigger, hopefully.
Can you go back up to create zoo again? I missed that.
Sure.
So create zoo, types, animals. Zoo. Okay. All right. Thanks.
Yep. I'll just scroll down a little bit there so you can see.
I'm muted, but I'm just cracking up at all of your. You don't have enough financial backers to feed any more animals. Rumph. All right. I'm having a good time.
I had to try to make something about this interesting, right? So let's add another animal to our zoo. Press 1 for animal or anything else to quit. With that, I'm just going to press 1 here. And what should we call this little animal? Let's call it Jojo. And we'll say a new animal was added. Let's add another animal to our zoo. We'll do 1 again, and we'll call this one Lola. And then I'm going to press, I don't know, Y to quit, just because I can. And after that, it says no more animals for you. Prints out that we've got 2 kangaroos that are coming out, even though we didn't necessarily specify they were kangaroos. So that's not great coding. But then we see it says jump, Jojo, jump. And Jojo jumped 1 meters north and is at position 1, 0. Same thing with Lola. Lola jumped 1 meters north and is at 1, 0. Well, that sounds kind of neat. We showed off how to use classes, and we said, hey, we can use a class to instantiate a kangaroo named Jojo and a different kangaroo named Lola. But what we didn't do correctly yet is we didn't figure out how to avoid a little bit of poor coding practice, where if I go through and to do exactly the same thing, but I change the jump amount for all of my animals by adding 100 to it. I'll go through this pretty quickly. 1 Jojo, 1 Lola, and I'm going to quit this time. And we see Jojo jumped 101 meters north. Same
Jojo just hulked out and just.
Well, junior developer me thought this was pretty good programming. Whatever the next step above junior developer me is, whatever we're calling that, is thinking, man, that's kind of almost sort of what I wanted to do, but not really. So with that in mind, what I really wanted to do is I want to protect this specific attribute. I want to make sure that I can't change this for every single one of my animals here, because it's going to just cause problems for us in the future if we're able to go in and change an attribute like that. So we've got a few different things to do. But first of all, what I want to show you is I made a new class called animal in example 2 here, and I am using ABC. Zach or Chad, you know what ABC stands for?
No.
I didn't either until quite recently. ABC stands for Abstract Base Class.
Gotcha. Okay.
Right. That's how I felt too. Essentially, what an abstract base class does is it sets up kind of a contract that is not really, something that the Python interpreter necessarily checks for you in one way or another, but it brings us closer to concepts that compiled languages often use, where you're able to say, I need all of my instances of this subclass to do something in a particular way based upon their base class. So in our example here, first of all, I just want to show you guys what we do in this example to help protect ourselves from changing the ability to jump from 2 meters to 100 meters. We're going to say that we've got this animal kind, this animal class that's an abstract base class. And it's got all of these speak, jump, run, describe, all of these methods that are not going to necessarily do anything right now, or they're going to look like they don't do anything right now. But they establish a relationship between this class and this class, my kangaroo class. Notice in my kangaroo class, it looks a lot like my old animal class did, except now I've got the init in my kangaroo, and I don't have an init in the animal class. So in this kangaroo class, we also don't have a jump factor or a jump attribute, because kangaroos all jump about the same distance, is my reckoning here. So we have that specifically set to 2. It's always going to jump 2 meters. I don't know how far kangaroos jump, probably further than that. And sure, they could jump different distances, but for right now, my point is we are trying to get that code that really messed with how the kangaroo was able to jump. It really messed with that class of that animal to be much more contained here. We're trying to prevent ourselves from causing issues for ourselves later on. So now we've got pretty much everything in here the same, except for those things of, we're hard coding the 2 and we're saying, we can't change that. We also have the animal and kangaroo classes that we're able to make now. So we can go in and we can run zoo02. And let's press 2 for kangaroo. And we'll still call this one Jojo. And 2 for kangaroo again. And we'll call this one Lola. And then when I press Q to quit, we see Jojo jumped 2 meters north and is at 20, and Lola did the same. And if we try to inject that data in here and we say anim.jmp was what we had previously, notice it highlights and it says, oh, that's probably hard to see. Statement seems to have no effect. Introduce variables for statement. It's not going to do anything. Animal.jump is, let's say, 100. If we do this, and we try running it again, to Jojo, we'll just do Jojo here. And we still see that Jojo jumped 2 meters north. So Jojo wasn't able to hulk it up and just take off. We are able to see that Jojo is relegated to just what Jojo's able to do, what that kangaroo class is able to do. Now, what's interesting about these ABCs is that we can force our kangaroos to always make sure, we can force our other classes, what's known as subclasses, to always use one of our methods. So our kangaroo class, if you notice, scrolling down through here, it's got to speak, it's got to jump, it's got to describe the repr. It does not have a run. If we use something known as an abstract method from ABCs, and we try to run exactly what we were doing previously, I'll click this, we'll go in to Jojo again, and oh, wait a minute. Type error. can't instantiate abstract class kangaroo with abstract method run. What that's saying is, hey, dummy, you made a subclass that doesn't have a method called run. You have to have that method called run. This is going to make it so that when we call on any animal, we always know that any animal is going to have that run method. So we can go in and we can make for our kangaroo a run method. And we can say return, no thanks, I'll hop. And if we just do that simple return, we can go in and we can say, press 1 for animal, 2 for kangaroo, 2. And what should we call this little kangaroo? Jojo again, and no more. And notice how it didn't error out for us because we gave it that specific abstract method, and we instantiated that abstract method. We added that abstract method of run into the subclass called kangaroo. Now, we could keep going with this, but I'm sure your brains are hurting a little bit. What questions do you have? Chad, I'm looking at you here. First of all.
So in what circumstances would you recommend that you would follow this procedure when you're defining a new class?
So I would say up until like last week, I saw classes as a way to just make an object, make a kangaroo, make a truck. What you're doing now with this methodology is we're saying, you know what? Somebody else, whether it's actually somebody else or me coming along later, will come along and change something about our code. They will try to add to our code. So this is something, when you're starting to use classes, I would say most of the time you're moving out of the realm of, hey, let's make a script to do this one thing to help with automating our task, whatever that is. And you're moving into the realm of, let's develop a service, let's develop an application. So I would say when you're actually in that development mode and you're saying, I'm using classes, I would say use the ABCs here. That way you can make sure you've got a thing and you always know exactly what that thing has to be able to do. Now, you also, kangaroos could add some other extendability to that. They can have additional methods beyond any that we specify for the abstract method, but they don't have to. So this guarantees that any person using an animal in the future in your code knows the methods that are available to it, at least to from the base class there.
Well, and the other advantage of inheritance is that if you notice where the passes are, if Sam were to add another, let's put it this way, Sam is actually creating the base class, and by popular demand, people who are using this base class or inheriting it decided, I need a new method, and they're not allowed to go access this themselves because the management told them, hey, I'm the software architect, you build like this. Well, I need a method that does that. So now you have your head wizard in charge that actually writes the core code because you're only letting one or two of your very best write that. First of all, I need you to buy into that one, Chad. You get that? Take the core code and put your very best coders on it, like the guys that are amazing, okay? Then you create a base class, which is like an ini file for programming. It's a template. You say, here's what you can do. Anything within this. And if by popular, let's say people would inherit that into their code, which then they can do all kinds of stuff as long as they stay within all the allotted methods. But here's like the killer, and it's like you got to get this. And I don't know if you're going to get it this moment. Suppose that you go ahead and you actually modify some of those where it just says pass rate now returns basically an empty set, does nothing. You actually make it do code. Well, you can do that when you inherit stuff and make things happen. But I tell you what you can't do, that Sam very nicely demonstrated, you couldn't add a new method to it because that's not part of the base class. Because ultimately, we're basically into social coding here, guys. We have junior programmers and we have like mega senior genius programmers, and we all got to work together, and everyone's new sometime. So you decide, you know what, I'm going to add a new method to the class animal and just put pass on the bottom, which you must do. Guess what that does? That doesn't break anybody who inherits it. Sure, they'll inherit that new method, but it just passed. You get it? Now, when this makes sense, when this really makes sense, is when you have a large team. And maybe we're all good programmers, but some are like brand new and they're going to make rookie mistakes. Then you know what you get to do for the next 2 years is you're going to write software off of base classes, and until you start to like, yep, you got your 5,000 hours in, or whatever the magic number is, 10,000 hours. Is that the number, guys? 5 years, 10,000 hours. Yeah, you got your 10,000 hours. You're really good right now, and then guess what? You start to move up the food chain in development. And I'll tell you, I actually, I always believed in this, but I'm pretty much with Sam. I'm sold on defensive coding. I always was, but this really is a very valuable application for classes. When there's more than one programmer on the team, when there's a bunch of them, you only need the wizard to say, here's the methods, here's the here's the classes, here's the base classes. Write all your code on this. That was great, Sam.
Thank you. Zach, did you have any questions?
No, I mean, ABC is the recipe to describe how subclasses are going to get created. So I get it.
Mm-hmm. Yeah, that's a very good way to put it. I like that. Yeah, so that's what I wanted to share. Sean, anything else?
Good.
I'm sorry, I didn't catch that. What?
I said I think Chad and Stu covered it.
Oh, okay, okay.
Well, Sean thinks that ABC has already been chewed. I wanted to say it too, but he beat me to it.
Yeah. On that note, I think we should call it a night, guys. Thanks for joining me, guys. It's been
Thanks,
fun.
Sam. It was great.
Thank you, Sam.